There is a moment, suspended above the cold waters of the East River, when a city reveals its ambitions. High steel arcing over tidal current, stone towers rising against a gray New York sky. A structure so vast, so deliberately imposing, that it seemed less like a bridge and more like a declaration, a statement carved in nickel steel and Maine granite that this city would not be stopped by water, by politics, by labor strife, or by the sheer audacity of what it was attempting to build. That structure is the Queensboro Bridge. Completed in 1909, it stretches across the East River connecting Long Island City and Queens to the East Midtown and Upper East Side neighborhoods of Manhattan, passing directly over Roosevelt Island in between. In the century and more since it first opened its decks to the people of New York, it has carried millions across that divide, carrying with it the full weight of American ambition, political conflict, engineering genius, and the relentless human desire to connect one shore to another. To understand why the Queensboro Bridge exists, you must first understand the New York of the late 19th century. Manhattan was an island in the most literal sense. To the east lay Queens, a borough growing rapidly, full of working families, expanding neighborhoods, and restless commercial energy, yet cut off from the economic heart of the city by the churning, unforgiving width of the East River. Ferries helped, but ferries were slow. They were hostage to weather, to ice, to the caprice of the tides. They were not enough for a city that was becoming the most consequential metropolis in the Western world. People had dreamed of a bridge here since at least 1804, when the engineer Benjamin Latrobe first proposed a masonry crossing between these two shores. A magazine article in 1833 imagined a bridge passing over Blackwell's Island, what we now call Roosevelt Island, anchored between the boroughs. John Roebling, who would go on to design the Brooklyn Bridge, proposed suspension bridges at this very location in 1847 and again in 1856. Each proposal faded. Each ambition stalled against the practical and political realities of the day. But no figure fought longer or harder for this crossing than Thomas Rainey, a doctor from Astoria, Queens. Rainey spent decades, literally decades, organizing bridge companies, filing legislative charters, sinking cofferdams into the riverbed, losing in court, absorbing setbacks, and beginning again. He won approval from Congress in 1887. He held groundbreaking ceremonies. He watched rival plans absorb and redirect his own. His name became, as one contemporary account recorded, a household word in Western Long Island. In the end, it was the creation of the unified city of Greater New York in 1898 that finally shifted the balance, folding Manhattan and Queens into a single government, making a city-funded crossing not merely desirable, but politically inevitable. Plans were finalized in 1901. The ground was broken that September. What followed was one of the most grueling, contentious, and complicated construction projects the city had ever attempted. The engineers settled on a cantilever design, a form of bridge that relies not on hanging cables, as the Brooklyn Bridge does, but on the structural integrity of balanced steel arms extending outward from central towers, locking into one another above the water. The bridge would cross the East River in 5 steel spans, threading across Roosevelt Island in the middle. The 2 great river crossings each required massive cantilever arms to reach outward from their towers and join at a central bent, a carefully engineered joint designed to flex horizontally with the expansion and contraction of steel through seasonal temperature changes, and to distribute structural loads between the 2 arms meeting above the water. The material choices were remarkable. Engineers specified nickel steel bars intended to be 40 to 50% stronger than standard structural steel of equivalent weight. Individual beams were rated to withstand loads of up to 56,000 pounds. The nickel steel I-bars could handle 85,000 pounds each. The decks themselves were engineered to carry 16,000 pounds per linear foot. Below, each pier consisted of 2 columns supported by elliptical arches 50 feet wide, faced with Maine granite and backed with Mohawk Valley limestone and concrete. Workers poured 14,000 cubic yards of limestone, 17,000 cubic yards of concrete, and 22,800 cubic yards of granite into those foundations. The Roosevelt Island piers sat on bedrock just below the surface. The Manhattan and Queens piers had to be driven more than 50 feet into the riverbed before they found solid ground. The project nearly collapsed, figuratively and, at moments, almost literally, more than once. A sympathetic strike by ironworkers in June 1905 halted construction for a full month. The Housesmiths' union walked out in January 1906, delaying progress by 4 additional months and leaving the half-finished structure exposed to the elements. Then, in August 1907, the Quebec Bridge in Canada, a cantilever span of similar design, catastrophically collapsed during construction, killing dozens of workers and sending a wave of anxiety through New York that was impossible to ignore. Engineers were summoned. Investigations were launched. The city's Department of Finance dispatched its own chief engineer to scrutinize every weld and beam. In the end, the Queensboro was declared structurally sound, though its planned elevated rail capacity was reduced from 4 tracks to 2 as a cautious concession to the moment. There were also human dangers of a more deliberate kind. In early 1908, disgruntled workers, consumed by grievance, driven to desperation, attempted to destroy one of the completed spans with dynamite. The attempt failed. The bridge endured. One newspaper estimated that 55 workers lost their lives during construction. These were men of the early 20th century's laboring class, ironworkers, masons, riveters, whose names have largely dissolved into the historical record, but whose sacrifice is embedded in every beam. The statistics of what they built are staggering. The 5 steel spans measured 370 feet between anchorages. Total length, including approach viaducts on both sides, reached 7 feet, nearly 1.5 miles of continuous structure. The steel towers above each pier rose 185 feet above the bridge's lower chords. At the time of completion, the western span between Manhattan and Roosevelt Island was the longest cantilever in North America, a distinction it held until the rebuilt Quebec Bridge surpassed it in 1917, and the second longest cantilever on Earth, trailing only Scotland's magnificent Forth Bridge. The total weight of the 5 steel spans, 52,000 short tons. The maximum height above mean high water, 135 feet. The total cost of the project, including land acquisition, approximately $20 million. The total time from groundbreaking to the day the public first walked across it, nearly 8 years. The formal opening arrived in stages. The bridge's lights were first illuminated on March 28, 1909. 2 days later, on March 30th, the decks opened quietly to the public, pedestrians, horse-drawn vehicles, and motor cars alike crossing together for the first time. The grand official celebration followed on June 12th, with fireworks exploding over the river, a parade lasting several hours winding through the streets on both sides, a beauty pageant crowning a queen of the Queensboro Bridge, and a full week of carnivals. The city had built something magnificent, and it knew it. Architecturally, the Queensboro was never content to be merely functional. Its towers, rising above those dressed granite piers, were originally crowned with Art Nouveau-inspired spires that gave the crossing the quality of a Gothic cathedral translated into industrial steel. The Manhattan approach ramp was supported on a series of Guastavino tile vaults, self-reinforcing ceramic arches, just 4 inches thick in total, that required no formwork once set and transformed the cavernous space beneath the ramps into something almost sacred. At its highest point, the vaulted ceiling soared 60 feet overhead. That space served across the decades as a food market, a garage, a sign shop, and a city highways depot before ultimately, after years of proposals and setbacks, reopening in '99 as the Bridge Market Retail Hall. Today, a Trader Joe's grocery store operates beneath those century-old vaults, perhaps the most elegant supermarket in the city. In the years after opening, the Queensboro became a corridor of extraordinary importance. By 1913, it carried 29 million people per year. By the early 1920s, 100,000 people crossed it daily. Elevated trains rumbled across its upper deck from 1917 until the line shut down in 1942. Trolleys ran on the lower level until 1957. The bridge adapted, endured, and kept carrying the city forward. It was designated a New York City landmark in 1973. It was renamed the Ed Koch Queensboro Bridge in 2011, a renaming deeply resented by Queens residents, who felt their borough's name was being traded away. The general public, with characteristic stubbornness, continues to call it simply the Queensboro Bridge. And every November, New York Marathon runners cross it westbound at the 15th mile, emerging from the bridge's strange, windswept silence into the erupting noise of First Avenue, one of sport's most electric moments, made possible by a structure that has been connecting people across this river for more than 100 years. A city is, at its deepest level, an act of faith. Faith that it is worth the effort to bring people together, to span what divides them, to build something that outlasts any single life, any single ambition, any single era. The Queensboro Bridge has been making that argument in steel and granite since 1909, and it still stands. If you found this history worth knowing, subscribe for more stories of human ambition in steel, stone, and concrete.